Recently, I'm working on the React schema form and React-schema-form RcSelect. Those front-end React application frameworks for form generation and presentation in the React applications. While working on the RcSelect, I have a live demo, and you can see the live demo just look at this. I'm just using small font. You can select the form, and you can pick up the data there in the dropdown. So the form is defined here, and the schema, which is a JSON schema, is defined here. This particular component, RcSelect, is an add-on to the React schema form, so that this can show people how to extend the React schema form with new components with their own customization. The reason we are creating this RcSelect component is because we want to display the dropdown sometimes dynamically on the application, which retrieve the dropdown values from another service. Let's say microservices or APIs running on the internet. So while upgrading this RcSelect component to the latest dependencies, I decided, okay, we need to deploy some APIs on the internet so that we can demo this feature to the user. So the first thing first, we need to create an API, and that API can output a JSON response to have a key value for the dropdowns. First, we need to create a specification. This is how the Lite4j framework works. It's the design-driven framework. You need to define the specification first, and here is the specification in Swagger editor. This is the OpenAPI 3.0 specification, and you can see it's very simple. We have some extra endpoint like our table, our data, and our values, as well as a list of hosts and the list values. While we are working on the demo application, we don't want to implement everything. We just need to implement this our data host. So basically, this is the prefix, and you give me a host and a name of the table, and I'll give you back a list of key value pairs in an array. So this is the API endpoint that we're going to implement. So the first thing first we need to do is we need to generate a project from Swagger editor. Produce for it. We can save this as a YAML file, OpenAPI YAML or OpenAPI JSON. I have both files saved into this folder in the GitHub repository, model config folder. We call this project let's say we call this project the light reference, because in the future we might just implement the entire reference application on top of this. And you can see this is exactly the OpenAPI YAML file we just look at from a Swagger editor. This is in JSON format. At the same time, we need to create a config.json to control how let code gen to scaffold the project. If you are using the command line, you can just compile the let code gen on your workspace, let's say network NT, and you can run this command line to generate the OpenAPI using API framework, output into the light reference, and using the OpenAPI YAML from this model config folder with this configuration. So this is the command line to scaffold the reference application. The other way to generate the code, you can use our website. Yeah, the codegen lightapi.net. And here you can use the single project generator. You can pick up the release. Normally we use a 2.0 release, which is a JDK 11. And you can select the framework as an open API. Then you can choose the model option. We just use online URL. You can see the for the model is here. We just use this YAML file. You need to make sure you select the raw. Okay, so just use this. Paste the URL here. And the configuration, we're using URL as well. JSON config, raw. Then we can generate. So the project generated, and you can see a zip file is downloaded. You can just unzip this into the the entire project here. You can unzip this into the let reference folder. So the generate code is exactly the same, like you are using the command line generate locally. So we've already generated the project, and you can see the project in the working directory. Let's say exist this. So this is a generate project. You can build using on the start server right now. Using Maven, clean install. Yeah, to start server, and the server is functioning, but there is no reasonable output because we didn't put any meaningful examples in the specification. So once we have the project generated, let's make some update to the endpoint for the R data, so that we can output some response given the name, the table, and the domain for the host. So this is a generate the let reference project. And you can see we have multiple handlers. This is the handler we are interested in, because this handler handles the request to the prefix /r data. You can see what we do is we get the host from the path parameter, and we got the name from the query parameter. And then we, based on the host name, as well as the name, the query parameter, either role or client, we return a list of key value pairs. The key value pair will be the dropdown. So it's very simple coding to get some dummy data returned from the API. So now we have the API updated, and let's see if we can execute this locally. Okay, now this is a Java 8. We need a Java 11 to compile the project because the project is generated with Java 11. Okay, I'll get a new. Yeah, the default Java version actually is JDK 11 on my computer. Only that particular terminal is Java 8. So this is Java 11. Let's start the server. This is build and start server. Okay, previously there were another session start to use the same port number 8443. Now I shut down the other session and this started. Now let's issue a curl command to see if the API works locally. Localhost 8443. This is the host, and we need a query parameter name equal to, let's say, a row. We got path not implemented. How could that be? Oh, sorry. Yeah, we forgot the prefix R data. Yeah. So this is the right URL. And now we can switch to client table, and you can see we got the list of clients: trusted, private, and public. That meaning the local API is working. The next step, we're gonna build a Docker container, the Docker image, and publish to Docker Hub. Then we can deploy this on the test cloud. Let's shut down this. To build a Docker is very easy. You can just try this. Yeah, this will build a local Docker image and publish to Docker Hub. We've already published this to Docker Hub already, so it's available in Docker Hub. And we are planning to deploy this to the test2 VM. So let's log on to test2 and take a look at how we can deploy it over there. In order to deploy the Docker container over there, we need, and on test2, it needs to register to the console, global console registry for the test cloud environment, so that other services, especially the portal router, can find this particular instance. We need to do some configuration change for the Docker compose, and as well as some of the config files. So let's take a look at the configuration. All the configuration is in the Light Docker project. And you can see I created a Docker compose, test2. And in the future, we're gonna put all the services into this Docker compose, which we want to deploy to test2 server. You can see now we have only the com network reference 100, the latest, and we map volume dot slash test2 reference to the internal config slash config folder for the external configuration. We pass in the status host IP as a Docker host IP, so that when we do the global registration on the console, the real IP address will be registered. The network mode is host, so we use the local host network for Docker. Let's take a look at the configuration file in test2 reference. We need this client.truststore. The client.truststore contains the certificate to connect to the server, which is a self-signed certificate, as well as it contains certificate to connect to the console server, as well as the root CA for the console server. As we are connecting to the console, we need a client.yaml, and we need from the default client.yaml, we need to update verified host name to false, because we don't need a verified host name for console, as console doesn't have have a domain name. It's only using the IP address to form a cluster. This is a console configuration. This is a console server address, and this is the token to connect to console. And for health check, we're using HTTP check. We're connecting the console using HTTP2. It's true. Logback is the control file for the debug log level. Now we are using arrow, but you can enable its debug on the restart server. You can see more detailed output. Service.yaml contains all the configuration to connect to the console. So you have console client implementation, as well as the registration and load balancing and the cluster support. This is the file to use for console connectivity. Value.yaml is a centralized variables for config files, and you can see here we are overriding the server dot. We are overriding the HTTPS port to 2498 and enable registry to true in server.yaml on the internal application. As you can see here, this application contains, after generation, it contains a list of configuration files. Almost every config file you can see, we have each individual module has configuration. So for here, the default port for HTTPS is 8443. We want to override this with the other value. And for the enable registration, the default is false. So this is the key we put into values.yaml to override this particular variable in configuration. So now we have everything configured in the Light Docker. We need to go to the test2 server. Here, we just need a pull. Previously, like all the update actually is checked into GitHub already. Here, we just need to pull the latest from master branch for Light Docker, and we are up to date already. You can see we have this compose test2, and we have the folder as well for the test2 folder. Contains all the configuration files. If we run docker ps, you can see we have this reference server started already, along with some other other processes from the Taiji blockchain, which is another product we have. To shut down and start server is very easy. Just docker compose -f docker compose test2.yaml down. You can shut it down, and you want to start up again, just use up-d. Since the server is already started, we don't want to restart it. This is started 17 hours ago, which is yesterday afternoon. Now we have this server deployed, and the server listening to a specific port, which is registered to the console. Now let's take a look at the console server. Yeah, from console you can see we have a lot of services registered here, and one of them should be reference. Yeah, this is a reference. You can see it's coming from this server, and with port 2498. So that meaning the service started and is registered to the console. Now we cannot access the server directly from the API. One is using a very specific port. The other is this particular VM is not visible to the internet. So we need to configure the Light portal. On the Light portal, we have a Light router instance deployed over there, so that we can use Light router instance to protect the API call. For example, for security, for tracing traceability as well as matrix collection, all the stuff, as well as the routing. So the light router is a $1 product for the single page application and the mobile application, as well as some external access to the server. It is a gateway, contains all the cross-cutting concerns for the gateway features. So let's take a look at the router configuration. The light router for the test cloud is defined in light config test. And here we have a light router folder. And within light router, we have a local portal as well as test portal. Okay, here is test portal. So for the light router, we need to make some change. The first change we need to do is we need to change the handler.yaml. And within this handler.yaml, we need to add one endpoint. This endpoint will be our data host. And for the wherein middleware handlers is using no-auth. No-auth is defined here. It goes to exception, traceability, correlation, course, header, path, and router. Those are the cross-cutting concerns will be run before the router route request to the reference instance. Another thing we need to change is the path prefix service.yaml. So any request prefix with /r data will be automatically routed to the reference API. This is the service ID. The other thing we need to do, we actually add this later on, but you can see we need to enable the localhost 3000 from HTTP and network nt github.io to access the light router instance, so that we can bypass the cross rejection. Otherwise, from another domain, you cannot access our API from the browser application, the React single page application. So those two lines we added. Let's take a look at let's restart the portal service. To start portal is very easy. You just need to log on to the portal server. On this server, you have a light router, test portal, and you can just docker compose down, and after this you can down up-d. This will restart the test portal and to handle the request from internet access. Let's take a look at this. Docker ps. You can see we have the router instance started here 6 hours ago. So this is newly restarted. So once we got this done, let's test it out to see how we can access the same API through portal. We can use curl. Just change the curl command a little bit. This is using the local server. Now we are using, let's say, light-api.net. We don't need this anymore, and we can say client. You can see it works. You return this value. And if we say we want to change it to row, this is the return value. So that meaning the APIs works. You can access from the internet because this is coming from my desktop. Now let's go to the React application to create two new forms which access this row and client dropdowns. This is the form RcSelect, and you can see I added those two. Those two are newly added. So this is schema definition. We have a name, and we have a row. The row is type is string. In the form definition, we say, okay, this is RcSelect, which is named the component. It takes action to get to have a get request to this URL. You can see the URL is exactly like https lightAPI.net/r data comment cid. Sorry, net1t name equal to row. This is a single select, and I add another one, dynamic multiple select. This select will have the same, like you have a name and you have an array for the client. The client is multiple, is true. It's still RcSelect component is get from this URL, which means you get from client. So the code is very simple. After you add those two test forms, you update the app.js to add those two in, and you start the local application. You can test out. The test applications in the example. So we just let's start this example application. It automatically creates a tab in the browser to load the application. Okay, let's select dynamic single. You can see the form is exactly the same I showed you. It's using this URL to get the data. And there is no definition for the dropdown. The data is coming from this URL. And if you look at this form, you can see you have admin and the user. It's exactly the same data we get from the API. So you can select, this is a single select. So you can see the row equal to user if you select user. Now let's select another form, dynamic multiple. You can see this is a multiple select. It's getting from the client table from the lightAPI.net. And this is the schema definition, which is an array of string. You can select multiple values. Let's see. You can select trust, private, public, and you can see all three are selected in the string array. You can remove the private. So this is the multi-select dropdown. So this means it's working, like from localhost 3000 to access the Light API on the portal site, which route the traffic to the reference instance deployed on the test2 server. When this works, we go to this GitHub repository. Within the GitHub repository, we actually deploy the example application to the GitHub IO for the live demo. So you can click here, you can see we go to the network.github.io React-schema-form RcSelect. And this is exactly the same application. You can select dynamic, and you can see the admin, user all loaded. If you choose another form, the dynamic multiple, you can see the multi-values can be selected. So it works same like you're running local, but actually it's running from net20.github.io. Remember, we already set up the course to allow those two domains to access the API from the browser. One from net20.github.io, the other one is localhost 3000. This is access from a separate domain, another domain. In fact, you can deploy this example application on the Light API, lightapi.net portal server, because that router instance does support virtual host. We already got multiple hosts over there. And in that case, you don't need the course to be enabled anymore because the access is from the same domain. So this entire tutorial actually, we went through the entire process to build one API, deploy this to the VM on the cloud, and set up the light router to route the traffic to the VM. Then we start a new single page application, and from the single page application, we access the API to get some data from the API. So this is very normal, like application deployment. You have backend API built using a microservice, and front end you have single page application or mobile application to retrieve the data from backend. And the entire process basically give you one example how you deploy this as a production-like environment in a very scalable way. The front-end application, we have this schema form, which is a very important component to build front-end application. It's not just dropdowns. You can see this is the project from React-schema-form Rc-select. But if you go to the React-schema-form, we have a live demo over there. And this demo, you can select numerous different forms, and you can see you can log in, username, password, remember me, and you can define numerous forms like online. You can change here. Whenever this is changed, the form is changed. So you can design the form from this demo application, and then you can use the form and the schema to generate a live form on your React application. Yeah, there are a lot of users like using this React-schema-form for single-page application. And this particular tutorial, we just combine the front-end React-schema-form as well as the back-end API service together, because we provide all the component to build applications. That's it. Thank you so much for your time. And if you like it, please subscribe and click the and thumb up on this video. Also, it would be great helpful if you can forward this video to your friends, whoever interested in API development as well as front-end development. Thank you. Bye-bye.